Jai Hind to all. In this video lecture, we are going to discuss the statistical graphics. Okay, so it will the part of unit 3. So statistical graphical we use basically to elaborate the data, elaborate the complex data that is very difficult to find with the help of the table or with the help of data in the form of the Excel. Okay, so let's discuss what is statistical graphics. So statistical graphic is the data presented in a graphical format. So whatever we have the complex data or difficult data, and when we compute that data in the form of the graphics, that is known as the statistical graphic. So based on that graphics, we make the statistic why we are lacking and what we are lacking, and why what we have to achieve to get that lacking. Okay, so basically use of the statistical graphics. So there are basically many used. We can say that it has very important point for any data presentation that is complex or difficult to express in the form of the table. Okay, so this is a reserve for material that is very rich in, okay, that is very complex or that is very difficult to achieve in the form of raw data. So what we draw some graphics. Based on that graphic, we analyze the data and we represent the data to the user, that is very understandable to the user. Okay, so basically statistical graph is the main use of that graphics is the data presentations, how we present the data, and on that presentation we have to emphasize the data that is very important to us. So based on that emphasis, we will prepare our strategies to why we are lacking and what we have to achieve. Okay, and the next use is minimize known data element. So suppose we have 10 entries in our Excel, okay, and but we have to draw, or we have to find the pros and cons, or we have to find the trends only based on the 5 entries in the column. So what we do? What we do the minimize the known data element. That means based on that 5 column entry, we just decide the presentation. Okay, we just draw the graph and decide the presentation. Okay, and minimize redundant data. We have to minimize the redundant data, that is the data that is more than one time. So we have to minimize and fill the graphs available area with the data. So whatever the data we have to draw all the data within the area, and we have to show the data variations. So basically statistical graphics are used for data variation, how our data is variations. Okay, and based on that variation we analyze the data, and based on that analysis of data we have to make the business plan. Okay, and next, provide proper context of data interpretation. So what is the context behind the data interpretation? We have to find with the help of the statistical graphics. Okay, so statistical graphics is used to represent the data in the graphics format. Okay, because graphic format is very easy to understand, very easy to analyze as compared to the raw data in the form of the Excel. Okay, or row and column. Okay, so there are many uses here. It reserved for material that is very rich, complex and difficult, and we have to present the data with the help of that graphics. Okay, and we have to emphasize the data, and we have to minimize no data element, we have to minimize redundant data here, and we have to fill the graphs available area with the data, and show with the help of that data we show the data variation, and we provide proper context for data interpretations. Okay, so what, so based on the some scales and shading, we have to draw the data, or we have to draw that data into the graphic format. So let's discuss what are the scales and what are the shading. Based on that we have to draw the graphics. Okay, so please place sticks to mark scales on the outside edge of the axis. Suppose we have to draw here the line graph. Okay, so we have to put these sticks to represent the axis. So this is the x axis and this is the y axis. Okay, and employ a linear scale. Okay, this is the linear and this is the linear. If we have to draw the another axis, z axis, that must be in a linear format. Okay, and mark scales as standard or customary intervals. That means, so these are the scales. Suppose this is 0, this is 10 and this is 20 and this is the 30 and this is the 40. Okay, so these are the scales at standard or customary intervals. That means the difference between 0 to 10 is 10 and 20 to 10 is also same. Okay, 20 to 30 is also same and 40 to 30 is also same. That means you have to consistent in the scaling. Okay, so similar, suppose here the scaling is 5, 10, 15, 20 and 25. The scaling should be consistent in nature. Okay, and start in numeric scale at 0. So always we have to start here 0. Okay, and then display only a single scale on axis. Okay, so one axis represents one scale, another axis represents the another scale, and the third axis represents the third scale we have. Okay, and provide scaling consistency. Again, there should be the consistent in nature. So it may be possible that 10 represent the 1000. That means, so whatever we hear the scale, we multiply whole the scale with the 100. Okay, suppose this is the 20, so 20 means here 2000. Okay, so whole the scale will be multiplied with 100, not only the 10. Okay, so if we go multiply whole the scale with the 100, we get the actual intervals or actual data. Based on that, we just plot the line or plot the graph. Okay, and consider duplicate axis or large scale data, or sometimes we have complex data and we have to analyze based on 3 axes. So you can use here duplicate axis for large scale data also. Okay, and the proportion, they should be equal in proportion between the two consecutive entries we have. Okay, and the lines, so based on that proportions we got some value and some dots, and after that you just plot the line. And labeling means that what x axis represent and what y axis represent, we have to show here so that anybody can analyze the graph means. Okay, and the title, the whole graph is must have some title. That means whole graph represent what. Okay, suppose here we have taken the months, here represent the sale per month. Okay, the title of this graph is the sales. Okay, that means this title, this graph represents the sales value on different months. Okay, and the interpretations of the number. So here the numbers can be interpreted by any value. Here the 10 represent multiply 100 and 20 represent multiply 100 and the 30 represent multiply by 100. Okay, so here interpretations of number is important here, because we are always not have the data in the form of 10, 20 and 30. It can be lakhs, it can be 1000 and it can be 100. So we just, for the ease, we have taken here 10, 20 and 30, and based on the data what we have, we just multiply these scales and we will recover the data on that graph. Okay, this is a technique. Based on that you have to go the graph. Okay, next, the first types of the statistical graph, that is the curve graph. Okay, so curve graph here represent the two axes. You can see that demand versus performance. So here you can see the demand versus performance. this represent the high demand, this represent low demand. Okay, low performance, and this represent the high performance, and this represent the low demand, and this represent the high demand. That means with the in these axis the demand will be increases, and in y axis the demand performance will be increasing. So what happened, how you can draw these curve graph. Okay, so here we start with 0, that means if we don't have performance, we don't have demand, and suddenly we increase our demand, and corresponding the performance will be increased. Okay, and then we increase the performance, correspondingly the demand will be grow. Okay, and finally we increase the performance and we got the demand will be increased. Okay, and this is the peak value. Here the performance will be at peak, at most. Okay, then demand will be at most. Okay, so if demand then going to decrease and performance will going to decrease, demand will also decrease. Performance decrease, demand decrease. Performance decrease and the demand decrease. And if performance decrease and the demand decrease. So is in these types where the two are basically proportions to each other. That is, performance is directly proportion to demand. So this kind of data if we have, so we got these curve graph. Okay, so if we have some proportion data, so proportion data will always give you a curve if both are directly proportion to each other. So next we come to the line graph. Okay, so line graph is a graph. So based on the data we have, we just put the line here. Okay, here we have number of houses sold. Okay, this is the number of month. So x-axis represent the number of month and the y-axis represent the number of houses sold. So based on that, we just analyze. In January we sold 50 houses. It now the 50 can be anything. Okay, 50 can be 500 or it can be 5,000. So based on the what we data have, either we have 500 or 5,000, we just multiply whole the entries here with that proportion. But they should be in equal in number. Okay, and we analyze. In February we just sold the 30. That means 300. Okay, and in March we just sold the 400, and April we just sold the 300, and May again 200, and January again 600. This is the data of a company which sold the houses. Okay, so based on the summarize. Okay, if the company want to summarize the our sale, so it can draw these line graph. Okay, at the end of January it will sold only 500, at the end of February, March, and based on that line graph, the point we recover from that data, we just put that line, and based on that the company will analyze that from January to February the number of sales will drastically decrease, that is 500 to 300 only, and at January February the number of sale increase, that is good for a company, and then April it is the performance will again degraded, and at May it will always also degraded, but at the end of June the company recover at its highest value. Okay, so this is the line graph. Based on the company will decide how our performance, how we will perform in the whole year or whole month. Okay, so based on that analysis the company will decide what we have to do for the next, so that we increase our performance. Okay, so these are basically the curve graph and the line graph. Hopefully, you understand deeply. So let's use the single graph. So single graph is used. That means there are two axes, the x-axis and the y-axis. In one graph, you will just put 4 or 5 values maximum. Okay. So this graph is used for the label identification. Suppose you have draw 4 to 5 lines. So it will be very difficult to understand what line for what. Okay. So for that we use this labeling, that is red is labeled for what and the y is labeled for what. Okay, and tightly packed curve, because 4 and 5 lines in a single graph, so that must be a tightly packed curve. Important or crucial data we placed here. So single graph is used basically for comparing actual and the projected data. So when we have to find the actual data corresponding to projected data, so we have to use the single graph, and based on that actual and the projected data, we find the data difference. So based on data difference, we find where we are lacking. So let's discuss this. This is the predicted y, and this is the predicted x, or you can use this is the actual value and this is the predicted value. Okay, anything. So red line is the predicted value and the blue line represent the actual value. So based on that, the actual will be more as compared to the predicted. You can find the difference between the two and we can conclude. Suppose this is the graph for January 2022 December 21. So this is the graph for the 2 years. Okay, here the y-axis represent the number of the scale in 50. Okay, 0 to 50, 100, 150, 200 and 250. So you can see here the predicted value is more but actually is less. So you can compare here again, the predicted value is more but actually is less. Here the predicted value is less but actually is more. Predicted is very less, actually is very more. Predicted is very less, actually is any more. Okay, so these kinds of graph is used basically in the medical. Okay, where you can, so what is the actual wavelength or heartbeat, but what is the actual heartbeat. Okay, what is the predicted heartbeat and what is the actual heartbeat. So to compare this kind of the heartbeat or any other variations you can find, so based on that you can find how your patient will be secure or in the critical positions or in the safe mode. Okay, so based on that prediction you can define this is the in the serious or not. So let's discuss the surface chart. So surface charts are used basically in the 3 dimensions. Okay, so if for surface charts we have to define the ordering, we have to define the coding scheme, and we have to define the label. So here you can see this is the one axis and this is the other axis. Okay, and this is the other axis, third axis, z axis. So based on that, here you can easily find these kind of the label. Okay, so based on the 3 axis we have to draw the surface chart. So based on that you can find this is the up and down, up and down. So based on that, here the 3 scale q1, q2, q3, q4. Okay, here the another scale, the name of the city Ahmedabad, Hyderabad, Kolkata, and these are the scales of the third scale, that is the up to 100, 200, 300, 400 and the 500. Okay, so this is the data that is 400 in the range of 400 and q1 range. Okay, 200 q2 range. Okay, so if we draw here for Kolkata 400 and q1 range. So when you have to go for more than 2 axes, So you can go for the surface chart. Okay. So based on that, the ups and down, and based on that the axis variate, you will analyze the data, and based on that analysis the company will provide the decision based on the analysis of that surface chart. Okay. So let's discuss the others. Scatter plot. So scatter plots basically used for the two dimension plot. Okay, it should be in the consistent intervals, multiple data set if we have, and the significant points if we have. Suppose we have here the data based on some height and weight. Okay, so we will put some dot here. There should be some scaling. Okay, 10, 20, 30, 40 something, there should be another scaling. Okay, height 2 feet, 3 feet, 4 feet. Okay, 1 feet, 2 feet, 3 feet, 4 feet, because we have to start from the zero. So based on that we have to draw these plots, and based on that dots we will analyze the relationship between the dots. Okay. So if we just find the same trend between these data, so you can go for the scatter plot. Okay, suppose this is another, this is the type of dot that is very easy to each other, very near to each other, that means it follow the same trend, and the dot that is very near to each other that follow the another trend. Okay, so these are the some exceptions in the graph. Okay, so scatter plot is used to find the trends between these scattered point. Okay, so based on that analysis we can find, so either it will be a part of this or it will be a part of this. Okay, suppose this scatter plot is used for the, suppose if you shop some grocery from online shopping portal. Okay, and you will generally find the grocery like atta, dal, or and etc. Okay, and then the other customer which don't go for the grocery, which go for the bathroom accessories. Okay, so we here combine the customer that generally buy the grocery. So what we do, we just provide the ad for only the grocery. So what discount we have on the grocery, we just proposed here. Okay, and the other customer which go for the bathroom accessory, so whenever there is a discount or any bathroom accessory, either the soap, okay, brushes and etc., we will show ad here. Okay, so because these two are the our customer, we have to focus on both of them, but strategically we show that ad. Okay, that discount that is suitable for you, that is generally buy, and based on that trend we just show the discount to customer that is very easily adapt that discount. Okay, or that is useful for that. Now next is the bar graph. Bar graph is the, here you can see there are some bars. Okay, so this bar represent the apple, this bar represent the orange, this bar represent the bananas, and this bar represent the kiwi fruits, blueberry, and the grapes. So consistent orientations represent these. Okay, and then meaningful organizations, and then bar spacing, differentiation, important and critical data, relating bar ordering, reference index, and the labeling. Okay, so here the number of people show the y-axis, and the fruits liked by that people represent the axis. Here you can say that the 35 people will have their favorite food apple, and the 30 number of fruits, 30 number of people have favorite fruit orange, and the 20 10 represent the banana, and the 25 favorite 25 people favorite fruit is kiwi fruit, and based on that this is the nicest fruit, this is the title of that bar graph, and this is the label. Okay, of x-axis, this is the y-axis, and based on that labeling we decide the number of people which fruits liked by maximum number of people. You can see that blueberry is liked by many number of people. Okay, so here we have to keep in mind the bar spacing, there should be equal space between the two spacing, differentiation important or critical data, and relating bar ordering and reference index and the labeling. Okay, so this is a represent here. You can show the data in the form of the bar. This is the segmented or stacked bar. So here you can see here 1, 2, 3 and 4, 4 stacks. Okay, so 4 stack, the first stack blue, that is the gasoline, and the second red color represent the food, and the blue color represent the rent, and the green color represent the utility. Okay, so this is the title of that segmented or stack bar, that is the expense by month. So data category ordering, you can see here the data are categorized. Okay, so that means this is expense of the gasoline, this is the expense of the food, this is the expense of the rent, and this is the expense of the utility. So similar you can find here number of people. Here this is the expense. Okay, this is the only 10, that is 190, that is 700, and so on. You can see here. Okay, here you can see the number of people which show the that expense. So that kind of expense, if you find the segmented value, you can go for the segmented or the stack graph. Okay, flow chart. So flow charts is the show the how the order of steps will be executed, and what are the orientations and what are the coding conventions. Here we start from here. Okay, this arrow represent we have to move here. So read A, B, C. Read clear. If A is greater than B, if true, then we have to go this way. If false, we have to go this way. If true, if A is greater than C, print A, and if B is greater than C, print B, otherwise print C. So this is the how the data is flow in the form of the flow chart. Okay, so order of steps, orientations, coding conventions we have to use. We have to use the arrow, we have to use the highlighting, and one decision at each step. This diamond box represent the decisions value. Okay, and consistency, order, and word all choices. Okay, so this is all about the statistical graphics. So hope so you will like the video. Thank you so much.